Hello, welcome to episode 137 in this series where I am programming an NES game live on Twitch. How's everybody doing? Hope everyone's having a good night. I am having an okay night. It's been a long day, but I figured we'd try and get some work done here. I don't know how far we're gonna get with what I'm planning, but we'll see. We'll try to keep it relatively short. I have some work I have to do for my normal work still tonight, so we'll try and keep this relatively short. So in the last stream, what we did was we adjusted tiled so that I can now take 8x8 tiles and place them onto the grid. Well, that was... That's weird. Hello, tiled. Why are you being weird? That's an 8x8. Huh. Oh, is that a 16x16 map? Oh, it is a 16 by... yeah, that's a 16 by 16 map. Okay, that's why. I was... no, it's not. Oh, yeah, it is. Okay. Anyway, this is the map that I was using for building stuff in the game itself. And this was the map we were building for testing things. This is an 8x8 map where we were able to select 8x8 tiles now and place them and know that they will fit within a particular grid for particular attribute setup in the grid. Here, that's a 16 by 16 overlay on the 8x8. That is separate from the actual tile size. That's what we were trying to get accomplished here. And so what we want to do tonight, or what I'd like to accomplish tonight, is to essentially take this data, export it, and be able to read this in with the asset tool and determine... There are a couple of things we can do here now. So because we're just working with 8x8s and we don't have to pre-allocate them into 16 by 16s, we have the flexibility of just importing a big dump of tiles like this into the editor to work with, almost like as a palette of tiles, which should help simplify things as long as we know what the attributes are roughly. That shouldn't be a problem. Because remember, the problem was that if I wanted to use a bunch of different tiles, I could make a bunch of tile sets here that were, in this case, they're 8x8, but really what they'd be is 16 by 16, and the problem is then you have as many tabs as you do tile sets, which in retrospect I guess I should have realized would have been super cumbersome. But hold on a second. Be right back. Sorry about that. Alright, so what was I saying? Oh, so I guess I should have realized in retrospect that the having to have a different tab for each 16 by 16 would have been annoying and frustrating. So this is a more optimal setup anyway. But so now what we need to do is we need to look at the map data that we just exported and essentially turn each of these 16 by 16 tile sets into a metatile that we can manipulate, and in doing so we can hey MDTA UK, how's it going? And figure out how to save that off using this image and extracting the tiles out of the image. And then we want to, let's start by just extracting them all. I'm not gonna worry about making them unique. We can worry about deduplication once we get the basics of the extraction working properly, and then we can worry about deduplication. And then probably subsequently what we'll need to know is, after we've deduplicated them, are we using too many tiles potentially for the ROM? The other thing we might need to know is, or might want to do, is tackle, I'm not sure I want to do that quite yet, the process of further sort of compressing this by saying, okay, well, not only can we turn each of these 16 by 16 representations into a unique set of 16 by 16s, but then we can also take the 8 by 8s and reference them by an absolute index in the tile memory, and you know, and then make the metatiles even more compact. But you know, we'll do small steps because that always works better. Make sure that we are working in the at each step of it. So going to the data that was just exported. Things are good. I caught up on your last stream changing the grid overlays and tiled. Will you add a toolbar button to toggle it on and off? Well, I'm just using the standard grid setup and tiled. I turned off the 8x8 for the actual tile size because I don't think that we care about that. Right, we know they're going to be 8x8, so the more important thing is the 16 by 16 for the attributes. So what was that called? That was called testing.json, I believe. It's saving it with compression turned on. Where that's in the properties for the map or something like that. You gotta turn that off. I know we did this at one other point too, but where did we do that? I mean, I guess we could incorporate the compression at some point, but it's much easier not to right now. Comma separated values. I believe that is what we want. Although I'm curious to see what these other export sizes look like, or data types look like, because this is just obviously a huge long string of comma separated values. 8x8 is only really important for text. Yeah, I mean, it's important for text, but at least at this point, does it need compression when you are processing the JSON CSV into ASM? No, I mean, not really. That's why I just turned it off. As far as your comment from before about the text, I mean, it is important. I mean, all the text is going to essentially be 8x8, but I think we could probably just still use the same overlay, because the attributes are what are the limiting factor here. What is this storing? This is... Oh, so this is just storing the data as base 64. I see. Uncompressed data. Okay. Alright, let's just stick with the CSV because it's what we were processing before and it's super easy to process. And the JSON library handles breaking that down into an array. So what we're doing now is we have a width of 32. It's only a grid, only the grid overlay. It doesn't stop you from placing. Right. Yes, exactly. The point of it is to help with the grid limitations, but obviously it doesn't limit anything else that we're doing. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Wow, this is a lot wider than I was expecting it to be. So that's 8. Just want to kind of break this up a little bit better visually for a moment here. So 1, 2, 3, 4. 1, 2, 3, 4. So that's our first 1, 4. 1, 2, 3, 4. So like this is the first row of 8 by 8. And the only reason that I'm doing this and now putting it back together is I want the whole first row just to be on one line here, just so we can talk about it and I can kind of visualize what I'm trying to do here potentially. So this first row, we'll use it as an example of what we're trying to do. So what we're trying to do now is we're trying to traverse this data and look at these 2 by 2 sets of data, which should be relatively easy to traverse. Because we can just index into it based on the width of the map. To collect the metatiles. And like I said, what we'll do is we'll compose the metatiles based purely on we'll compose the metatiles purely based on what's on the image that's being used here, and then worry about any further compression later on. Yes, so the indexes that you're seeing here, or the indices you're seeing here, are the PNG tiles referenced by this calendar screenshot tile set here. So this XML, we should actually export that as well. So let's do that. Is it not over here? Oh, it's on the desktop. Okay. What is that overlay here? 210 frames? I don't understand. Is this Windows telling me this, or? I'm confused by this. So there's no bitmap and pixel data that can be compared for. Yeah, there is. I'm really confused by what that overlay. Oh, why? Press H to hide. Yeah, get. Why is that running? This is software that I got for the new. I installed for the new case that I bought. I don't know why it's decided to put an overlay on my application here. It should stop doing that because I didn't ask it to do that. Let's get rid of that. Let's get rid of all. No, don't do that. Don't do that either. You know, my first mistake was just installing software for my case. Just because it has LEDs in it, apparently you need to install software, and I should have known better. Okay. Can we just talk about how presumptive and the level of audacity a company that makes cases has to think that they have the right to hijack your system just because you installed their software to control the RGB lighting in it? That is pretty amazing. Okay, so sorry, I'm looking at what you're saying here. Does the JSON call to the PNG tiles? Yes. So there's no bitmap. Yes, we can look at the PNG in the external file to do the deduplication. Yeah, all those tools are trying to be helpful by slowing down my machine and bothering me at the worst possible moments, instead of just letting me take care of it when I'm ready to take care of it. It's like at work we have software management stuff that's installed that in the middle of the day decides it's going to do an update to the MacBook that I'm working on. It's like, great. Well, I was in the middle of working on something, but either I dismiss this and I let you reboot my machine now, or I have you do it randomly in 2 hours when I've already forgotten that you told me you were going to do it. Shouldn't let me get distracted by this. All right, so yeah, so let's export that tile set before I forget that that's what we're doing, and I keep ranting about stupid software and the people who make their stupid software. No, it's not here. Why don't I see it? That's the P. Oh, wait. Where? It is in the assets. Why didn't it show up? Oh, because the drop down. Right. Okay. So let's export this. Okay, cool. So this refers to the actual image that we're using. It tells us our tile count, the image width and height. So 240 by 380. It's 30 by 384 by 48. Yeah, that's the right tile count. So if we just take any of these tiles here, 399, 399. So $3.99 divided by 8 will give us 49 as our row, and then 49 times 8 gives us 392, so that's plus 7, so it's 49. 7 by 49 if we were to go into the tile set. Oh, I shouldn't have closed that. Just want to make sure that I'm reading this right before we implement something and I find out that their indexing is off. So what did I say? I said it was 8 down. 1, 2, 3, 4. This is too small for me to see. 1, 2, 3, 4, 5, 6, 7, 8. Right, that's 8, and then 0, 1, 2, 3, 4, 5, 6. That doesn't sound right. The top of the screen is what kind of tile? It is a sand tile. How? 399. Hey Miak, it's going. I'm kind of at a point where maybe we actually start working on game implementation, like design stuff, more. Actually, it's funny. What was it? Last weekend? I think it was last weekend. I'm pretty sure. John Blow posted a conversation he had with Casey Muratori about game design, and it was oddly, uh, oddly in parallel with the way I've been feeling about game design versus game programming and engine programming, because he asked John Blow the same question that I was kind of thinking about, which is like, it's one thing if a designer tells you, hey, the game needs to do this, right? Like I can program that, and that's what we've been doing, is me going like, hey, the game engine needs to do this, the game engine needs to do that, and we set out to do it, and more or less after a few streams we get it to do that, right? But there's a difference between that and actually designing a game that you can play that's fun. And so they were discussing, and I think they took the video down. I think John took the video down. I'm not sure why. Maybe they didn't want to have that. I still have it downloaded on my phone. Thankfully, I just happened to download that. But I just, that's the part of the game design side of things for me that's difficult. As I've said before, it's one thing to just code up stuff and know what needs to be done. And yeah, you have to kind of struggle through technical limitations and API limitations and researching and stuff like that. But that's all really concrete. Making games and designing a game and making it be fun is less so. And so, while we've had some interactions with enemies that you can fire, weapons at, and we've even done some things where now I can in the game keep track of groups of enemies that you've destroyed, so that we can spawn bonuses on the screen while you're playing the game. It's that doesn't make a game. So what came up recently was that we were trying to kind of figure out how to make the building of the backgrounds easier for the artist and for myself, and that's what we're doing here. So getting back to this, if that seems like a lot more tiles than what I thought. The image is, well, I guess that's transparent. So going back to the JSON file for a minute, image height is 240, but that seems like it's more than that, right? Are there XY coordinates on the screen? I said it was 30, right? So that seems, I guess that's about right. I don't know why I'm doubting that. The math shouldn't lie here. So the only thing that I'm confused about, let's see, so 384 based on the fact that I've got 399 divided by, that's tile 399 divided by what? I guess it shouldn't necessarily be 8, should it? No, it should be 399 divided by 30 and get to 13 rows of 30. Is that right? Times 8, 104. Three by 30 gives you 13. So 13 by 8 is 104. Is that the number of horizontal if the, oh, that's the height is 30, so the width is 384. Okay, that makes more sense. That's what was bothering me, because it seemed like it was weird that it was so narrow. So 384 divided by 8 is 48 tiles. That's what I wanted to do. So, okay, so 399 divided by 48 gets you about 8. So 48 times 8 gets you 384, 15. So it's 8 tiles. 1, 2, 3, 4, 5, 6, 7, 8, and then 15 across. 1, 2, 3, 4, 5, 6. This is looking better already. 7, 8, 9, 10, 11, 12, 13, 14. Yeah, okay. My counting was off, but that makes sense, because that's a sand tile. That's what it's like. I'm a writer, not a programmer, but I get how you feel. How do I make this fun? Isn't a concrete question you can find an answer to. Right, yeah. Or, depending on what kind of writing you're doing, it's like, how do I make this engaging, right? Like, if someone asks you to write something very cut and dry, you can probably do it without much, too much thought, other than trying to, be succinct and and intelligible and stuff like that. But to actually make it engaging to the reader, beyond just being factual, is the hard part. Okay, so that checks out. That math should work for us to be able to do the lookup into the actual image, and we can revert this back to its original. Whoa, that's too far. Okay, so back into its original form, we have our tiles here, and we can index into that no problem, based on knowing how big the map is, to generate our 4x4 metatile pieces. Now, the cool thing about this is we should be able to then kind of reverse the process that we had before, whereas before we were generating the metatiles, and this is something I was thinking about before. Whereas before we were generating the metatiles manually, and then and then bringing into the map the metatiles as separate tile sets, and then just kind of having to mesh them up together, and then the problems that brings in when you make a mistake in that mesh, in that merging process. This should actually simplify that, because this should allow us to have the metatiles get exported from the map rather than the other way around. And then the really cool thing, there are a few cool things about that. One is that if we need to change a tile for a whole host of metatiles, by the time we're done, we should be able to take advantage of the compression by actually allowing, or it's not even compression so much as it's like shorthand, and by the fact that we're using that shorthand, it compresses it. But anyway, the point is that it will allow us to do things like do sort of more what's the word I'm looking for? Expedient updates to shared tiles or similar tiles. The other thing I was thinking about is that one of the things that we have in the metatile editor is the ability to annotate collidable pieces of the map through the metatiles, which always kind of seemed a little bit clunky. I'm thinking that we should be able to, through the object layer, add another type that's 8x8, or maybe another type of tile that's 8x8 or something, that we can place on here and use that for the collision export that we support on the 8x8 tiles. I think that will be really cool, and actually simplify the process of building the map even further, which is exciting, because then that means that most of the map building is going to be done here, and then we just export out to the right format for the NES. So enough yakking from me. Let's see if we can figure out some code to, as we process the exported map, generate our lists of metatiles. So this is the part where we're processing our JSON. And what we want to do, so that's the tile layer in the JSON. That's layers. Went all the way to the top, and okay, that's what I was looking for. So that's the type, and it has the width and the height, which we want. And we check the compression, and we get the data. So here is where presumably we would take the individual tiles and start converting them into sets of metatiles. I'm debating if it makes sense to keep the raw linear buffer for now of the data. I don't think it does. Well, it does in the sense that maybe we just leave it while we're writing the code to process the metatiles. All right, so what I want to do is we have the width and the height. One thing that this breaks is the map data right now that we're storing is only 8 bits. As you can see here, we're going to have to change this to, let's say, 16, which is going to be a problem for this. Because all of our stuff prior to this was 8 bits, which is fine. I mean, it doesn't break anything horribly other than where we know the compiler will complain. That's why I like to type languages, though. At work, I'm using more and more, or not more and more, I'm using TypeScript and JavaScript and that kind of stuff. And while certainly some of those frameworks are way better than what you used to do with PHP or, you know, older web development frameworks, it's still kind of a mess when you start dealing with things that are not typed properly, and all the weird things you do with the different frameworks that, you know, and you end up losing the typiness of the type of the stuff that you're working on, and then you get into weird problems where you've removed key components that could potentially, you know, have been detected if the compiler knew about type and knew about the things you were manipulating, but because we had to use magic and, you know, flexible scripting frameworks and everything had to be hidden behind layers and layers and layers, you can remove something critical and everything compiles and everything looks happy. I mean, yeah, I like TypeScript, but compared to JavaScript for sure, but web development on a daily basis makes me shake my head and groan, because it is it drives me a little bit crazy. All right, so we have a width and a height, and what we want to do is we want to use those. I'm gonna alias these to these values for the purposes of shorthand here. And what we're going to do is now we're going to traverse the map 16 by 16 tiles. Do I want to divide by 4 there? Maybe I do. That's the height in tiles, right? Actually, I just want to divide. Do I want to divide by half? They're 8 by 8 tiles. Yeah, so just want to divide by half. Yeah, JavaScript is awful. I mean, the thing with the way you used to work with things like PHP, right, is that it was just a mess. Like there were no rules of how to kind of separate the pieces out. And so you got frameworks that tried to do that, where you'd say, okay, you know, I have my model view control, right? That's the paradigm that everybody wants to use. And so you have your model view control, but the problem is that PHP really made it super easy to break that model when you can just intermix PHP into your HTML and JavaScript into your HTML and JavaScript into your PHP, and you know, you do all these tricks to inject code to make certain things work. And I can say that, you know, I do like that Angular is a little bit more structured and handles that stuff a little bit better. Like you do have more separation. C# and .NET is all about that MVVM. Yeah, I mean that's what all the frameworks are these days, right? Is about that separation to avoid the problems that you ran into with PHP and those you know, and CGI bin. I mean, there were other problems too, but that was one of the biggest things, you know, that you'd end up with pages that have HTML, JavaScript, and PHP all interspersed because the person writing the code, I mean, myself included, just out of, you know, trying to do things quickly, there's no discipline in terms of how things are separated out. And so it's really difficult to see what's going on then. So this is mostly C. There is a little bit of C++ mixed in for convenience. So like true C doesn't let you do this with the initialization of the variable in the for. I'm using a little bit of C++ for the JSON code parsing because I was using a C library and it was difficult and it really made the code extremely complex. So it's mostly C. There's some C++ mixed in. Yeah, so it's not I mean, it's hard to find anybody writing pure C at this point anyway, because there are so many little advantages of what you can get out of using even just some stuff in C++, even if you don't go template crazy and write code that's, you know, creating templates all over the place and allocating objects all over the place. So again, it was mostly for convenience. I guess I should be consistent with, is this an int? It is an int, so it would be good if I were consistent there with that. So, okay, so that gives us our, this gives us our metatile width and height, and let's be consistent here with our typing. So the compiler won't yell at us for this, at least, even though it's yelling at us for a million other things that we're doing that are maybe not the best in this utility. And yeah, so this is going to traverse the tiles as far as the grid, the red grid there goes. And what we're going to do is we're going to just read, you know, these two tiles, and then those two tiles, and then we're going to jump and read these two, and those two, and those two, and those, and we're just going to keep doing that until we run out of tiles. To read, and for now, because I'm just kind of writing this basic code here, I'm going to cheat and just kind of shove everything into a data structure for the moment, just for the purposes of confirming that what we're doing actually looks right. So this is going to be a a deck of Uint 16.4. I'll explain that in a second. This is definitely not what we're going to keep with. So this is a C++ structure, this deck thing. It's like a vector in Java, or I guess an array in JavaScript or whatever, but you can push and pull things out of it. I'm just doing this for the sake of being able to verify that we've pulled everything out of the table correctly. So what we'll do is we will have a Uint 16 of 4 called metatile, and then we're just taking our x, our y times our map width plus our this should be x times 2, right? I guess it was stupid to do this divide because I'm making this everything else more complicated. So thought I was helping myself here, but ultimately this is just easier to do. Like this. We'll just increment by 2s, and then this is good still, but then we don't have to do that because it'll just be the right index there. And then metatile, and this is just a straight up copy of, could even be, I don't know that this is really buying us anything, but we can say, you know, copy 2 bytes this way, right? That's definitely, you know, if we were doing more than 2 bytes, I could say definitively that this was better, but I don't know that it is. I don't think it's worse to do a mem copy this way for this. So the only thing we have to do here, because we're copying 2 bytes, we only have to do these 2 copies. And what we're doing is we're saying, okay, copy the first 2 bytes starting at the y offset by the width of the map plus the x, right? So we're just multiplying our y by the width to go down the map, and then the x is the offset in, and then we've got to do that for the next row, because yeah. Let's see, this guy we're gonna ban, and you two, you're gonna be banned too. All right. Look at me. I must be doing something right. I've banned 2 people. It's like being a legit streamer now. All right, so that should copy that, and then temp list will push this back. I mean, this is an awful way to do it. Doing this pushback is actually copying the content into the newly created item that we're putting into this deck. anything performant or that you actually care about, you do not want to do that. But for the purposes of just making sure that this works, it will be good enough. So we'll fix that once we feel good that our logic here actually makes sense. So let's go to this, and let's change this map to be testing.json. Yeah, the band hammer. Sounds a lot cooler than it is, I guess. Yeah, it's actually the first time I've had to ban anybody on stream, which isn't a bad thing. An array. What are you complaining about? An array cannot be initialized with a parenthesized initializer. Are you complaining about this? Or no, you know what? It's probably complaining about. Yeah, it's complaining about my deck. Can you not do a deck of a fixed array size type like that? All right. Well, you know what we can do. Let's make this a UN32. Now we're getting really weird. Because these are... Oh, no, they're not bytes, though. They're 16-bit. We'll have to use a 64-bit, but... Yeah, we're getting really weird here now. So what we're going to do is we're just going to use the 64-bit to represent all the bytes, because 2, 4, 6, 8... Yeah, so all 4 bytes... all 4 values will be 64 bits, so... Now what we have to do is this is no longer an array. We want to mem copy this, and then wow. So here's where you go. This is where C and C++ get dangerous, right? So what I'm doing is I'm copying our... Oh, this should actually even... This is... Oh, this is not going to work. I guess it's good that we ran into this. So it's not going to work because the map buffer is... Oh, no, wait, it's 16, right? Okay, it is 16. So I had the wrong number of bytes anyway. But, so each of these values is 2 bytes. We're going to copy it into the first 4 bytes because it's 2 values at 2 bytes, but it's, 4 bytes here. And then we're going to do crazy math here. We'll do this by being a little bit more reasonable and saying, okay, we want to copy this into the address that is this thing. The address of this thing, as if it were a UN16 pointer, we're going to add 2 to it. So, is this particularly safe? I mean, it's not bad in the sense that I know that I'm doing the right thing, right? I'm incrementing 4 bytes, and I'm only copying 4 bytes. If this were something I was doing on a string, and I wasn't limiting my copy by a fixed value of the destination, or there are a whole set of scenarios where something like this is not safe, and that's where you get into problems with lower level languages like C and C++, because they let you do this kind of stuff. But again, for the purposes of what we're doing, this should be fine. I mean, if it crashes, then it crashes because I messed something up. But at the same point, let me do something I wanted to do that was a little bit more funky that you'd normally not be able to do. Looks like we may have, let's see. Oh, it didn't run. So Visual Studio has been doing this weird thing lately where it takes a while to start up. It'll just sit here doing nothing, and then suddenly process memory and all that other stuff pops in. All right. Well, that was that. So let's take a look at temp list, and so that's 1680. So let's start by making sure that this count makes sense, right? Because if we go to this and we say, okay, so it's 384 divided by 16, that's 24. 24 and 15, 360. Already something is sounding not correct to me, because we should only have what did I say, 360? Yeah, we should only have 360 tiles, metatiles. So this is 32, that is 210. Oh, wait a minute. No, I'm not even doing that right. So it's 32 by 210. Maybe that is okay. 32 by 6, it's oh, it's 32 by 8, right? Because that's how many pixels it is. Well, it's just 32 tiles. It doesn't matter. I don't know why I'm getting hung up on that. So, no. Not by 16 by 2. So it's in half, right? So it's 16, and then 210 by half is 105. 105 by 16, 1680. Okay, all right, that checks out. So I forgot that we're dealing with the map and not the tile set. And the map is obviously bigger than the whole tile set. So that's okay. So that's the right number of items. And so then we look at these numbers and they're huge, and you go, well, how does that correlate to what we actually have in the map, right? If I open up this, what's the easiest way to see this? I guess we could switch this over to hex here, and you will start to see an emerging pattern, which is that we have, I believe, the right values. Switch to the programming view here. 18F, my guess is probably 399. It is. So 399, 399, and then can I see the tile that I've selected? It's the same tile below it. So sorry, I'm jumping around here. Same 4 tiles. Okay, so that looks good. And then the next one is 399. Okay, so that's all good. And then it should change for the next meta tile set. We should get, yeah, so we're getting, what is that, 20 hex? Because remember, these are 2 bytes each, so 20 hex is what, 32? Yeah, so 32 by 32, or not by 32, just 32, 32, 32, 32. That is all looking good. So it looks like that actually worked. And we pushed our 64. You know, I almost wonder if that's... I mean, I don't want to do it in this deck here like we're doing, because there's no value to that other than the laziness of being able to push it back into the deck and not have to worry about allocating the right amount of memory for it. But representing those as 64-bit values is actually interesting, because it would give us the ability to immediately tell if we have exactly duplicate metatiles by just comparing the values, right? Like if we, oh, wait a minute, there's even, oh, that's even better, right? If we use those values essentially can be not a hash, but a check to see if we already have that metatile saved off effectively, right? We can say, like if we look at, go back into the debugger. See, sometimes these things happen because your brain, just from programming a lot, will point you in a direction that unexpectedly has good side effects, and you're like, I wish I could have said that I deliberately chose that direction in this case, but I didn't. But it's not a bad thing. It actually worked out nicely, because what I can say is, like, okay, right here is a good example, right? These two values are numerically equivalent. So right off the bat, what we could do is we could have some structure where we can do easy deduplication of these metatiles by just comparing the values and looking to see if we have them already, right? And you can see these repeating patterns because we have a lot of tiles that are very samey over here, right? Like we're just using a lot of repeating patterns. Now over here we'll get less of that, but what I'm getting at is the nice thing about it is that it's really easy to do that comparison because they're just 64-bit values. We don't have to do individual comparisons against the individual 16-bit values because we've stored them this way. And then what's even better is that then when we store the map, we can store the map based on the new metatiles that we're finding and putting into a list of metatiles. So the list of metatiles could just be a list of 64-bit values that if it's 0, well, 0 wouldn't work. We'd have to keep account of where we've actually stored those values into the 64-bit array. But we have an array of 64-bit values where we populate these metatiles, and that essentially maps. The only thing I would say is you could use. I wouldn't want to use a 64-bit index. Normally what I do, and I've done in this application, is I'll do something like I'll create an array that's just basically really sparse, but uses the numeric value as essentially a hash into the array for the sake of like being able to look up, have we seen this value before or not? In this case, because we're using a huge 64-bit value, I wouldn't want to do that because the sparseness of it is not quite it's not quite memory efficient even for this inefficient tool that we're building. So we'll still do a search, a linear search on if we have the 64-bit value to look up the index, and then that shouldn't be too bad as long as we're not going to ever have a huge enough set of metatiles where it's going to be where it is going to be a huge cost to do that lookup. Will this comparison have to be done every time, or will you be able to cache the metatiles? I mean, for now, I'll probably do it every time. I don't think the game is ever going to be big enough where we're going to have so many assets and metatiles that we would want to speed it up to that level. Like if we were building a 3D game with hundreds or thousands, tens of thousands of assets, then probably, yeah, we would want to we would want to have a fixed ID, and we wouldn't want to be rebuilding everything all the time. We'd want to be just kind of cross-referencing what we had done before and adding to it, or shifting things around, and only fully rebuilding if we have to. Is my guess. I can't say that that's 100% the case. I know Casey Muratori is doing he's been working on his asset management system on Handmade Heroes, so that might be worth looking at if you're actually curious about how that would work in a larger 3D game. I don't know exactly. I think probably it would be done based on unique IDs and hashes, but because again we're dealing with such limited amounts of content, and we could probably, by the end of the game, I imagine that if it takes 2 or 3 seconds to reprocess, or not even by the end of the game, by the end of development, if it takes 2 or 3 seconds to reprocess everything in the game, I'd be surprised. I mean, even if it took 10 seconds, we're not talking about something where it's a massive 3D game where they've got to reprocess all their 3D assets and shaders and textures, and and it can take a very, very long time to rebuild the assets for the game. And you hear about like these really long cycles of getting assets made available for the game. Let's see. So yeah, let's do this. Let's switch away from the deck here, and let's start by call it discovered metatiles, I guess. And I don't know. How much memory would that be if I do 8 bytes times 100? That's 800 bytes. I don't know why I brought up a calculator for that one. 800. I mean, that's nothing. Let's say there's 200 and. All right, so basically, if we don't see it in the list, we just put it into the location of next metatile and increment that. So from there we say for int m is equal to 16m is equal to 0, and m is less than next metatile. So if next metatile, discovered, what do I call it? Discovered metatiles m is equal to metatile found mt equals true, right? And if not found mt, and right now we don't even care where we found it. We just want to make sure that this approach is going to work and condense down the list. So discovered metatiles, next metatile is equal to all right. So if we found it, then we don't add it. Actually, I don't know why I'm doing it there. If we really need to know what it is, obviously we have to save off the index there, but let's see how we're doing now. So next metatile is 0. Why? Oh. No, I had it right. I shouldn't have done what I did. It's because we got to finish the traversal. This should be, if not, anyway. Brain fart. Let's try that again. Oh, did I went too far. An undo buffer too far. Okay. Oh, what happened? Access violation. Map buffer. X. Y. Y is at 54. Metatile. Access violation at that. No, stop it. The speaker down here has Alexa on it, and decided that it thought I said that. How come this wasn't a problem before? Tell me. Metatile. Value 0. Why did I overrun my buffer? I sure did. Right? Next metatile is okay. Well, here, let's make this much bigger. Much bigger. Try that again. We had too many metatiles to fit. I guess it didn't compress too well in the intermediate section. Although that's odd. If discovered at metatiles M. I feel like this is busted. Yeah, I know, there's a stack problem. I get it, because something is wrong. So metatile is this value. Discovered metatiles M. M is what value? M is 0. So if we go say discovered metatiles is our huge array. I want to look at 8-bit integers, please. That's our first value. And I have no idea what that is. It should be the same thing in hex, right? It is. So if that is equal to that, then found is true. If not found, oh, damn semicolon. Wow, that hasn't bitten me in a long time. You saw it, right? There was a semicolon there, so it evaluated to true here. It evaluated to false here, and then it fell into the braces. I haven't done that in a long time. Alright, so it found it, and yeah. So that's why it needed 1,680, because it was marking them all as unique, which is not good. Okay, so 10F is 271 unique metatiles. Okay, that's not bad. So that compressed it actually pretty well. I mean, and again, you know, it's not... We're not really going for the most efficient solution here, although I don't, without changing the data, without it being lossy, where you change some things around to make it more efficient, I'd be at a loss for how you'd make this part more efficient. Like you could say, okay, well, if it's something where you look at this and you look at this, and they're basically the same, except this has this extra tile in it. You can say, well, is it really worth having an extra metatile for just this one? I mean, how many occurrences of that do we have? And that's part of where you do some data analysis to determine how efficient your map is in terms of metatile reuse. That part of the compression might be useful because, with space being what it is, well, I guess it's, sorry, I'm like thinking through this in real time. So, I mean, you could, yeah. So the trade-off is if you store the metatiles like we are right now, where they're individually stored, then that analysis would be useful. But if you then go the next step further, where you're using a pointer into the tile set for your metatiles, so that you're only ever storing these tiles once, even if the metatile definitions are stored separately, it's like then you're talking about how much savings are we getting by saying, well, we have only one definition of a metatile versus two, in that scenario versus the scenario of where this is one metatile and this is another metatile, all with unique image data. That's a little bit more, that's a bigger difference in size, where we might care if we have enough of those. So I don't know. These are all interesting things that I think about. I don't know how important they are. I don't want to go too far into them because they may not ever matter, depending on how big the cartridge is or what our constraints are in general. Okay, but the good news is that looks like it's working. And then, of course, the next step is to then reconstruct the map, re-indexed using those metatiles. And I think I'm just thinking about how I want to structure this versus the next stream, because we've been going for about an hour and 20, a little bit less because I started a little earlier than I started the recording. Let's get this into a map buffer that is that's the less interesting part of this. The more interesting part of this is to take that data that we extracted from the discovered metatiles and then load the image of the map stuff, and then extract the tiles out of it. But that's more work than I think I want to take on tonight. Just because, like I said, I want to end with a little bit of time to get to some stuff I gotta finish for tomorrow. Well, let's do that. Let's allocate a buffer for. I don't know that that's even worth doing. I think I'm going to keep this one short. I know that's rare for me, and we didn't really accomplish a whole lot, but we at least got the code that's assembling our metatiles working, and we have a way of storing them efficiently, and I'm good with that. I don't think I need to go too far beyond that right now. One thing that I'd like to do starting soon is I'd like to. I think I'm going to start recording episodes that are not all live streamed. I'll still try to keep it at least one episode live streamed a week, but start kind of picking up the pace of the recordings and posting them at whatever rate they're being recorded, so that we can pick up the speed here. I'd like to get this moving faster and spend more real time working on this for a variety of reasons. One, to obviously finish it for myself, but also there are a few people who have actually pre-ordered the game. Some have pre-ordered it way in the beginning, and while it certainly wasn't a lot of money, I, don't want them to feel like they're losing out on their money for this game that they've pre-ordered. That's been going on, in development for a little while. So I think that's going to be my plan moving forward. I don't want to not do the streams because I really like doing the streams. I like the folks who actually come by pretty regularly, and then the people who just chat, kind of hop in to ask questions or just see what's going on, which is fun. And just kind of want to keep that connection going because that's a lot of fun and part of what makes this interesting. And I've connected with a lot of you through the live streams. So so thanks for watching. As always, if you want to reach me on Twitter, I'm at Clervis. You can reach me on Video Game Sage as Zelius. In the Discord, I'm also Zelius. And you can email me if you have any questions. I have a Patreon. You can buy me a coffee if you find that these things help. I know that the zero-page episodes have once again slowed to kind of a halt, but that's just because of the amount of time they take to produce. They are very, very time consuming. I appreciate everybody who's watched them and gotten interested in NES Dev because of them, and have been on the Discord to ask more questions and have started building their own stuff. It's pretty great. So thanks for watching, and I will catch you on the next episode. Have a great night and have a great rest of the week. Hopefully I'll see you Thursday. All right, take care. Bye.